Take a slow breath. The air filling your lungs is not still. It is racing eastward at the speed of a passenger jet, dragged by a rotation so steady, so ancient, that your body mistakes it for stillness. Beneath that motion lies a quiet bargain between atmosphere and ocean, crust and core, magnetism and light. Break the bargain, stop the spin, and the planet becomes something else entirely. Something stranger than any disaster you have ever imagined. Dim the lights. Let your shoulders drop, soften your jaw, and breathe out slowly. In the next 2 hours, we will walk down the chain of consequences, one link at a time, from the air above your roof to the iron at the planet's center, and discover why the Earth's rotation is not a feature of the world, but the architecture holding it together. Before we dive in, if you love exploring quiet thought experiments about our planet as much as we do, take a second to like the video or subscribe and tell me where you're listening from and what time it is. I read every comment. Now, let's begin. To understand what happens when something stops, you have to understand what it was doing in the first place. And the first thing worth saying about the Earth's rotation is that you have never, in your entire life, perceived it directly. Not once. The clouds do not blur. The stars do not streak. The cup on your nightstand does not slide. From the moment you were born, your body has been moving at roughly 1,500 kilometers per hour relative to the planet's axis. And your inner ear, which is exquisitely sensitive to acceleration, has registered nothing at all. This is not because the motion is slow. By any reasonable measure, it is extraordinarily fast. It is because the motion is unchanging. Your body, the air, the oceans, the bedrock under your house, the satellites overhead, the moon, all of them are participating in the same enormous, gentle, invisible spin, and uniformity hides everything. So before we ask what happens when the spin stops, let us settle into what the spin actually is. The Earth turns once on its axis roughly every 23 hours, 56 minutes, and 4 seconds. That is one sidereal day, a single rotation measured against the fixed stars rather than the sun. The slightly longer 24-hour solar day exists because the Earth is also moving along its orbit, so it has to turn a little farther each cycle to bring the sun back to the same place in the sky. These two numbers, sidereal and solar, have shaped every clock, every calendar, every harvest schedule, every navigation chart we have ever produced. They are not abstract. They are the heartbeat of the species. The speed at which the surface is carried depends on where you stand. At the equator, the ground beneath your feet is moving at about 1,670 kilometers per hour. That is faster than most commercial jets fly. Stand near the equator in Quito, Ecuador, or in Libreville on the western coast of Africa. Both cities sit within a few dozen kilometers of the line, and you are being hurled eastward at a velocity that, if it were ever made visible to you, would be terrifying. Move toward the poles and the speed drops. At the latitude of New York or Madrid, the surface speed is closer to 1,200 kilometers per hour. At the latitude of London or Berlin, closer to 1,000. Stand exactly at the geographic North Pole, and the speed beneath your boots is, in a meaningful sense, zero. You simply turn in place, like a slow ballerina, completing one quiet revolution every 24 hours. This gradient, fast at the equator, slow at the poles, is more important than it sounds. It is the reason the Earth is not a perfect sphere. The constant outward push of rotation, what physicists call centrifugal force in the rotating frame, has been pulling at the planet's body for billions of years. Over geological time, the Earth has responded by bulging at the equator and flattening at the poles. The technical name for this shape is an oblate spheroid. The numbers are easy to underestimate. The radius of the Earth at the equator is about 21 kilometers larger than the radius at the poles. That is the difference between standing in the sea at Quito and standing in the sea at Tromsø. 21 kilometers of rock, water, and atmosphere redistributed by spin alone. The planet you live on is not round. It is a slightly squashed ball, sculpted by its own motion. Now, hold that image. Because almost everything that follows in this script is a consequence of the fact that the Earth is shaped by its rotation, and what was shaped by rotation will, when rotation ends, no longer be held in that shape. You probably think the consequences of stopping the Earth would be obvious. Day and night would freeze. One side would burn, the other would freeze. People who watched a school physics class would shrug and say, of course, everything not bolted down would fly off at the speed of the surface. The textbook answer is a simple cinematic catastrophe: wind, fire, ice, followed by a long, boring cold. That picture is almost entirely wrong. Or rather, it is wrong in its emphasis, wrong in its order, and wrong in what it leaves out. The truth is layered, slow, and far stranger than any disaster movie has ever portrayed. It involves the air becoming a wall, the oceans abandoning their basins, the crust beginning a sluggish reformation, the magnetic field fading from the sky, and a long, almost geological era during which the planet learns to be a different kind of world entirely. To explore this properly, we are going to need to make one careful decision at the outset, and we are going to need to make it honestly. There is no real physical mechanism by which the Earth could simply stop. None. The angular momentum stored in our planet's rotation is one of the largest reservoirs of energy in the inner solar system, and it cannot be erased without an event that would, by itself, end the conversation. A collision capable of stopping the spin would also vaporize the surface, melt the crust, and probably eject the moon. So this is, in the truest sense, a thought experiment. We are going to assume, gently like a story, that the Earth's rotation is brought to a halt by some hand that does not also incinerate everything. We are going to imagine the spin slowing over a few minutes, or being switched off cleanly, depending on which version of the question we are asking. And then we are going to follow the consequences as honestly as physics allows. The rest of the script is governed by that single quiet permission. There is something else worth saying before we descend into the cascade. The Earth's rotation has been slowing for as long as there has been an Earth. Long ago, in the Hadean Eon, more than 4 billion years past, our planet turned much faster. A day was not 24 hours. Estimates suggest it was closer to 6. The sun rose, climbed, and set in less time than a modern workday, though the exact path of slowing through the long Archean is still being debated. The reason it slows is the moon. Tidal friction between the Earth and its large companion drains rotational energy from our planet and transfers it, in a slow gravitational handshake, to the moon's orbit. The moon, in response, drifts farther from us at a rate of about 3.8 centimeters a year, a number first measured directly using laser reflectors left on the lunar surface during the Apollo missions. The lengthening of the Earth's day, then, is not an abstraction. It is a measurable, ongoing process. It has been confirmed in the growth bands of fossil corals, which record the number of days in a year by laying down daily ridges. Coral fossils from 400 million years ago show roughly 400 days per year, meaning each day was around 22 hours long. The geologist John Wells in 1963 was the first to read this fossil clock and report it. His paper was a small revolution in how we understood time itself. So the Earth has always been slowing, very gently, by almost nothing each century. The thought experiment we are entertaining tonight is not a violation of nature in its direction. It is only a violation in its speed. We are taking a process that should take hundreds of billions of years and compressing it into something the imagination can fit inside. Stay with this for a moment, because the slowness is part of the meaning. The Earth's rotation is not a switch, it is a drift. When we ask what happens if it stops, we are really asking what the planet would look like if a very long, very quiet process were ended in an instant. What would be exposed in the air, the seas, the rocks, and the iron core when the gentle pressure that has been shaping them for billions of years suddenly let go? Before we follow the consequences outward, let us build the floor we will be standing on. There are 5 things to know about Earth's rotation, and these 5 things will return again and again across the rest of the story. Every consequence we trace will hang from one of these 5 facts, like ornaments from the limbs of a tree. The first fact is that rotation produces angular momentum. Angular momentum is the spinning equivalent of regular momentum. Once an object has it, getting rid of it is hard. The faster the spin and the larger the object, the more angular momentum it carries. The Earth, being both massive and rotating, carries a colossal store of it. This store is shared with the atmosphere, the oceans, and even the molten metal of the core. Every part of the system is participating in the same vast, coordinated motion. The second fact is that rotation produces the Coriolis effect. In the rotating frame of the planet, anything that moves over a long distance, wind, water, missile, migrating bird, appears to curve. In the northern hemisphere, it curves to the right. In the southern hemisphere, it curves to the left. This is not a force in the deepest sense. It is a consequence of the fact that the ground beneath the moving object is itself rotating and at different speeds at different latitudes. The mathematical description of this effect was published in 1835 by the French engineer Gaspard Gustave de Coriolis, working on the analysis of water wheels, with no idea his name would later be invoked every time anyone tried to explain a hurricane. The Coriolis effect is the reason hurricanes spin. It is the reason trade winds blow from the east. It is the reason ocean currents form gyres rather than straight lines. Stop the spin, and this effect ceases to exist. The third fact is that rotation creates the equatorial bulge. We have already met this. The 21-kilometer surplus of rock and water at the equator compared to the poles. The bulge is the planet's response to centrifugal force over geological time. It is, in a sense, a frozen sculpture of Earth's spin. If the spin ends, the sculpture begins to relax. Slowly, but decisively. The fourth fact is that rotation drives the geodynamo. Deep inside the Earth, an outer core of molten iron and nickel churns in great convective rolls, partly stirred by heat from the inner core and partly organized by the planet's rotation. This swirling, electrically conductive fluid generates the Earth's magnetic field, which extends out into space and shields us from the worst of the solar wind. The full theoretical framework for this dynamo was developed across the 20th century by figures like Walter Elsasser. In a series of papers published between 1946 and 1947, Elsasser proposed that slow fluid motions in Earth's molten outer core could sustain a planetary magnetic field by self-induction. Without rotation organizing the convection into orderly rolls, the dynamo's behavior would change profoundly. We will return to this in detail later, because what happens to the magnetic field is one of the strangest and least obvious consequences of all. The fifth fact is that rotation produces day and night. This is the most obvious effect, the one any child could name, and yet it is also the foundation of the entire biosphere. Photosynthesis, animal sleep cycles, weather, ocean mixing, the diurnal rhythm of carbon dioxide in the atmosphere. All of these depend on the regular alternation of light and shadow that rotation provides. End the rotation, and you do not merely end the cycle. You replace it with something else, something that the entire history of life on Earth has never had to face. Two facts will carry us through what follows. The planet stores an enormous reservoir of angular momentum, and rotation has shaped every layer of the Earth: air, water, rock, magnetism. The rest of the architecture we will meet as we go. And as we step through them, you will find that the planet you thought you knew is held together by forces so quiet, so steady, that no one ever bothers to mention them until they are gone. Now we turn to the question of timescale, because how the Earth stops matters enormously to what happens next, and there is no single right answer to how fast. There are at least 3 versions of the thought experiment, and each produces a different planet at the other end. Honesty requires that we name them before we descend into the consequences, because much of the popular discussion of this question has muddled them, and the muddling is where the worst misconceptions come from. The first version is the instantaneous stop. The Earth's surface stops in less than a heartbeat. Everything not bolted to the bedrock continues moving at its previous velocity. At the equator, that means everything, air, water, sand, animals, buildings, is suddenly traveling eastward at 1,670 kilometers per hour relative to the now stationary ground. This is the version of the thought experiment that produces the famous cinematic catastrophe. And it is, in physical terms, almost meaningless, because there is no force in the universe that could decelerate the planet's surface in an instant without simply destroying it. The instantaneous stop is a cartoon. We will visit it briefly because it is what most people imagine, but it is not where most of our attention will go. The second version is the rapid stop, a slowing that takes minutes to hours. This is still cataclysmic, but it is at least imaginable. Wind speeds would still reach lethal extremes, but the kinetic energy would be released over a longer period, and the surface would not be instantly scraped clean. Some structures might survive, some life might survive. The atmosphere itself would slosh in great hemispheric tides before settling. The third version is the gradual stop, a slowing that takes years, decades, or centuries. The planet has time to redistribute its angular momentum through tidal interactions, atmospheric drag, and ocean friction. By the time the rotation actually reaches zero, the surface has long since ceased to be the violent place of the rapid stop, and the planet's inhabitants, if any remain, face a different problem entirely. The slow problem, the structural problem, the problem that does not go away with time, but only deepens. For most of this script, we will work with a hybrid. We will visit the rapid stop briefly to honor the cinematic question and dispense with it. Then we will spend the bulk of our time exploring what the world becomes once the spin is genuinely gone. What the air does, what the oceans do, what the crust does, what the magnetic field does, what life does, what the sky does. We will treat the stopping itself as a single quiet event, like a candle being put out, and devote our attention to the long, strange, beautiful aftermath. That is the picture so far. A planet shaped by rotation, rotation slowed gently by the moon, 5 fundamental effects holding the system together, and a thought experiment carefully framed to let us see what would happen if all of that were quietly switched off. Now we begin the descent. We will start where the consequences arrive first, in the air above your head, and we will work our way down, link by link, into the deepest places of the planet. The first thing to go is the wind, or rather, the first thing to go is the absence of wind. Because what you call calm air on a quiet morning when the trees are still and the lake is glass is not actually calm. It is moving, with you, with the planet, at the surface speed of your latitude. The reason you do not feel it is that everything around you is moving at the same speed. Wind, in the everyday sense, is only the difference between two parcels of air moving at different velocities. Stop the ground and leave the air alone, and that difference becomes catastrophic. Imagine standing on the equator the moment after the planet stops. The earth beneath your feet is suddenly stationary. The air above you is not. It is still moving eastward at 1,670 kilometers per hour because nothing has told it to stop. From your perspective, a wind has just begun to blow. But that word is too small for what is happening. A Category 5 hurricane has sustained winds of around 250 kilometers per hour. The wind that arrives the instant the Earth stops is more than 6 times faster than that. And because the energy carried by moving air rises with the square of its speed, this wall of air is over 40 times as destructive as the strongest hurricane ever measured. It is not a hurricane. It is something for which we have no word, because nothing in the natural history of our atmosphere has ever produced it. Slow down here, because the implications take time to land. A wind of that speed is no longer fluid in the everyday sense. The kinetic energy contained in moving air scales with the square of the velocity. Doubling the wind speed quadruples the energy. At 1,600 kilometers per hour, the air is carrying so much energy per cubic meter that it ceases to behave like a breeze and begins to behave like a battering ram of compressed gas. Anything in its path is not blown over. It is shattered, then aerosolized, then carried away. Trees do not bend. They lift slowly from their roots and join the wind. Buildings do not lose their roofs. They become part of the storm. The very topsoil is carried up from the bedrock and gathers over hours into a vast quiet cloud high in the atmosphere, a global haze that will take years to settle. This is the picture you have probably seen in cinematic explorations of the question, and it is, broadly, correct. But it is also incomplete in 2 important ways, and the incompleteness is what we are here for. The first incompleteness is geographic. The wind speed is not uniform. At the equator, it reaches its peak, 1,670 kilometers per hour. At the latitude of New York, it drops to about 1,200. In London, around 900. Approach the poles, and the wind drops further still. Stand at the geographic North or South Pole at the moment of the stop, and you would feel almost nothing. The air above you was barely moving in the rotating frame, because at the pole, rotation is rotation in place. The local linear velocity is essentially 0. So the wind from the stop is not a planetary blanket of equal violence. It is a band, tightest and fastest at the equator, fading toward the poles. The first survivors of the rapid stop, if any, would be in the high latitudes, in Greenland, in Antarctica, in northern Siberia. The poles, which are the most hostile places on the modern Earth, would, paradoxically, become the safest places at the moment of the catastrophe. The second incompleteness is temporal. The wind is not a permanent feature. It is transient. The atmosphere is not infinite. It has friction with the ground. Over hours and days, the great eastward gale would pour its kinetic energy into the surface, into mountains, into the ground itself, until the air finally came to rest with the rest of the planet. Some of that energy would go into heating the atmosphere. The air, compressed and friction burned, would warm dramatically, raising surface temperatures across the equatorial band by tens or even hundreds of degrees. But eventually, the wind would die, the catastrophe would end, and the world would face the next slower problem. The next problem is silence. Because once the wind has finally come to rest, the atmosphere on a non-rotating Earth begins to behave in ways no atmosphere on a rotating planet ever has. There is, in theory, a clear fix for the wind problem. The atmosphere stops moving. It comes to rest. The world becomes calm again. After a few weeks, the dust settles. The skies clear. Surely, after the violence is over, what remains is just a still, peaceful Earth, lit by an eternally fixed sun on one side and shrouded in eternal night on the other. That is the next misconception, and it is one of the most stubborn ones, because it sounds so reasonable. A planet without rotation, the intuition says, is a planet without weather. The atmosphere goes to sleep. That hope collapses the moment you look closer. Because the Coriolis effect was not the only thing organizing our weather. The fundamental driver of weather on Earth has always been the temperature difference between the equator and the poles. Hot air rises, cold air sinks, the atmosphere flows. On a rotating Earth, this flow is broken into bands and cells by the Coriolis force. The trade winds, the westerlies, the polar easterlies. On a non-rotating Earth, those bands disappear, but the temperature difference does not. If anything, on a non-rotating Earth, the temperature difference becomes more extreme than anything we have ever known. Picture the new sky. The sun no longer rises and sets. It sits, fixed, somewhere above one half of the Earth. The other half is on a permanent night. On the day side, the surface absorbs sunlight continuously, never cooling. On the night side, the surface radiates heat into space, never warming. Between them is a narrow ring, the terminator, where day meets night in an eternal dawn or dusk. The temperature contrast between the two sides is enormous. The day side, depending on latitude and atmospheric circulation, can climb well above the boiling point of water in some scenarios, while the night side plunges to temperatures lower than anything Antarctica has ever recorded. In the most extreme models, the night side becomes cold enough for atmospheric gases to begin freezing onto the surface. Not just water, but carbon dioxide, perhaps even nitrogen. And so, instead of weather as we know it, the non-rotating Earth develops a single planetary scale convection pattern. Hot air rises continuously from the subsolar point, the place directly beneath the fixed sun. This air spreads out in all directions, cools as it travels, and sinks somewhere beyond the terminator on the night side. Cold air from the night side flows back toward the subsolar point along the surface. The whole atmosphere becomes one great wheel, with hot air rising in the middle of the day side and cold air converging from every direction along the surface to feed it. There is no Coriolis force to break this wheel into smaller cells. There are no jet streams. There are no hurricanes. The weather has not gone to sleep. It has been replaced by something simpler, slower, and more relentless than the weather we knew. A perpetual planet-spanning circulation dragged along by the temperature gradient between an eternal day and an eternal night. Stay with the strangeness of this for a moment. Because what the non-rotating Earth would have, that no part of our current Earth has, is a sky that does not change. The clouds, if any form, are organized by the Great Convection Wheel rather than by passing weather systems. The sun does not move, stars do not rise. There is no morning, no evening, no afternoon. There is only the slow drift of cloud structures across an unchanging dome of light. And on the night side, a perpetual canopy of stars, locked in place, drifting only because the Earth still moves around the sun once a year, slowly carouseling the constellations across the night sky. In this configuration, a year takes on a different meaning. The Earth would still orbit the sun, even without rotating on its axis. So, over the course of 365 days, the side of the Earth facing the sun would slowly change. The half of the planet that is in eternal day at the start of the year would, 6 months later, be in eternal night, and vice versa. From the perspective of a hypothetical observer on the surface, this would mean that the sun would, very slowly, drift across the sky over the course of a year, completing one full circuit annually rather than daily. A day would no longer exist as a unit. The smallest rhythm of the world would be a year. We are getting ahead of ourselves. The atmosphere is only the first link in the chain. The next link is the ocean. And what the ocean does is, in many ways, the most surprising and most spatially shocking consequence of all. To approach it, we need to return to a fact we have already met, but have not yet truly looked at. The Earth is not a sphere. It is an oblate spheroid. There are 21 extra kilometers of radius at the equator compared to the poles. And those extra kilometers are not just rock. They are, in significant part, ocean. The Earth's oceans today are a thin film of water averaging less than 4 kilometers in depth, draped over a planet whose shape is itself bulged at the equator. But the water is not draped uniformly. It is held in its current configuration by the balance between gravity, which pulls it toward the planet's center of mass, and centrifugal force, which pushes it outward at the equator. Combined, these two forces produce what oceanographers call the equilibrium sea surface, the shape the ocean would take if it were perfectly still, with no waves, no tides, no currents. This shape, technically called the geoid, is itself an oblate spheroid. The ocean is fattest at the equator and thinnest at the poles, in the same way the planet is. Now, switch off the rotation. The centrifugal force vanishes. Only gravity remains. And gravity, on a sphere, pulls toward the center of mass, equally in every direction. Suddenly, the equatorial bulge of the ocean, the extra height of water that has been held up there for billions of years by spin, has nothing holding it up. It begins to flow toward where gravity is now strongest in relative terms, the poles. What happens next is one of the most extraordinary geographic transformations in the entire thought experiment. Over a period of months to years, depending on viscosity and atmospheric drag, the world's oceans drain away from the equator and pile up at the poles. The result is not a planet covered in ocean, as it is now. It is a planet with two enormous polar oceans, separated by a vast equatorial supercontinent, a continuous belt of dry land circling the entire planet from east to west, where the seafloor of the Atlantic and Pacific has been left exposed. This is not a small change. The new equatorial supercontinent would include not only the dried beds of today's tropical oceans, but also vast areas of what used to be temperate and even subpolar seafloor. Looking at the planet from space, you would see two great blue caps at the north and south, separated by a continuous band of brown and grey rock running all the way around the equator. The continents we know today, Africa, the Americas, Eurasia, Australia, Antarctica, would all be merged with this new exposed seabed. Antarctica would be no longer at the bottom of a South Polar Ocean, but the highland of an ocean. North America and Asia would be linked across an exposed Arctic seabed. The notion of a continent, in the modern sense, would dissolve. This rearrangement was modeled in detail by the cartographer and analyst Witold Fracek, working with the geographic information firm Esri in a now famous 2010 visualization. Fracek's analysis showed that the polar oceans would be enormous, deeper than any ocean we currently know, and that the dividing equatorial supercontinent would be roughly 40,000 kilometers around, a single, unbroken ring of land that you could, in principle, walk completely around without ever crossing salt water. His maps revealed something that no amount of verbal description quite captures: that a non-rotating Earth is not the Earth we know with the lights left on. It is a fundamentally different geography. Stay with this geography, because almost everything that happens to life on Earth in the long aftermath of the stop depends on what the new continents and the new oceans look like, and our intuitions about climate, weather, and biology are calibrated to a world that no longer exists in this scenario. There are two great oceans now, one in the north and one in the south, each centered on a pole. They are not connected at the surface. They cannot exchange water, heat, or species without crossing land. Between them runs an enormous, continuous belt of exposed seafloor, much of it well below modern sea level, even after the redistribution. Much of it suddenly elevated only because the water has gone elsewhere. The new global map looks almost nothing like a school atlas. It looks like the planet has been recut by a hand that did not believe in any of our boundaries. The transition itself, from old map to new, is its own slow drama. The water does not simply slide poleward in a single afternoon. It moves, sloshes, settles. The first major flows would carry tens of thousands of cubic kilometers of seawater per hour out of the equatorial basins toward the poles. Coastal cities, even those at high latitudes, would see sea levels rise dramatically, perhaps by hundreds of meters in some regions, as the polar oceans grew. Cities on the equator, even ones we currently consider far from the sea, interior cities like Brasilia or Nairobi, would, over time, find themselves on a coast, made not by the rising tide, but by the falling one, as the ocean withdrew steadily westward and eastward toward the new polar basins. Some places would experience both effects at once, depending on local elevation and the precise contours of the seafloor. Out at sea, the disappearing equatorial ocean would expose features no human has ever seen with daylight. The mid-Atlantic ridge, that great undersea mountain range running from the Arctic to nearly the Antarctic, would emerge from the water in long sections, drying into the longest exposed mountain chain on Earth, 16,000 kilometers of stone that no human eye has ever seen above the waves. The hydrothermal vent communities of the deep ocean, those bizarre ecosystems built around heat and chemistry rather than sunlight, would find themselves, for the first time in their history, in air. The black smokers along the Pacific's spreading centers would belch into the atmosphere rather than the sea. The chemistry of the surface would shift. Sulfur compounds, iron, manganese, hydrogen sulfide, all of which had been confined to the deep ocean by water pressure and stratification, would now diffuse into the lower atmosphere, changing the smell of the world. Stop here for a moment, because there is something almost theological about this image. The Earth has always been, in human imagination, a planet of 2/3 water and 1/3 land. That ratio has shaped every map, every voyage, every poem, every prayer. The non-rotating Earth has a different ratio. The water has not gone away. It is still here, still in roughly the same volume. But its arrangement has changed so completely that the old descriptions no longer apply. We would have to invent a new vocabulary to talk about this world. Not continents and oceans, but caps and belts. Not coastlines and seas, but the great long shore where one immense polar ocean meets the only continent there is. And there is a second, less obvious consequence of the ocean redistribution that almost no popular treatment mentions. The polar oceans, fed by all the water that used to be at the equator, would be deep, very deep. In some regions, depending on the local topography, the water column would exceed 20 kilometers. That is roughly twice the depth of the Mariana Trench, the deepest point in the modern ocean. The pressure at the bottom of these new polar oceans would be unprecedented in the history of liquid water on Earth. No surface organism could survive there. Even the creatures we currently know from the deepest trenches, the snailfish, the amphipods, the strange microbial mats, evolved in a world of much shallower oceans. The new polar abyss would be, in a real sense, a place where life as we have known it has never existed. Above these abyssal polar oceans, the water itself would also change. With the planet no longer rotating, the great wind-driven currents of the modern ocean, the Gulf Stream, the Kuroshio, the Antarctic Circumpolar Current, would cease to exist. The Coriolis force that bent water flows into vast rotating gyres would be gone. The winds, organized into a single planetary convection wheel as we discussed earlier, would still drag at the surface of the polar oceans. But the resulting circulation would be radically simpler and slower. Heat would mix more gradually. Oxygen would penetrate to depth more reluctantly. Nutrients would be distributed differently. The ocean, in short, would become a different kind of ocean. Stratified more completely, mixed less efficiently, hosting whatever life could survive in a world where its rules had been rewritten without warning. Now we turn to the land itself. Because while the air and the water have been rearranging themselves, something quieter and more profound has been happening to the rock beneath. The equatorial bulge, that 21 kilometers of extra radius at the equator, was not just water. Most of it is solid earth. The bulge is a feature of the lithosphere, the rigid outer shell of the planet, and of the underlying mantle. And it was held in that bulged shape by the same centrifugal force that shaped the ocean. End the rotation, and the rock, like the water, has nothing holding it up. The textbook answer is that solid rock cannot flow, so the bulge would simply remain. That picture is almost entirely wrong. On geological timescales, rock does flow. The mantle of the Earth, despite being technically solid, behaves as a viscous fluid over millions of years. It convects. It rises and falls in great slow plumes. It deforms. The lithosphere itself, though more rigid, eventually responds to long-term stresses by bending, breaking, and reshaping. The Earth's bulge is not a fixed sculpture. It is a dynamic equilibrium, maintained by the ongoing tug-of-war between gravity and rotation. Remove rotation, and the equilibrium tips. The bulge begins, very slowly, to relax. How slow is the question? In the immediate aftermath of the stop, in the first years, decades, even centuries, the visible response of the solid Earth would be subtle. The lithosphere would begin to experience new stresses as gravity, no longer balanced by centrifugal force at the equator, pulled the equatorial regions slightly more strongly toward the planet's center. Over thousands of years, the equatorial regions would begin to subside, fractionally, while the polar regions would experience uplift. This redistribution of mass would produce earthquakes of unprecedented magnitudes, not as a single sudden event, but as a long geological era of seismic readjustment. Every fault on the planet, every subduction zone, every continental margin would feel the shift. This was modeled in part by the geophysicist Walter Munk and others, who studied how the Earth's shape responds to changes in its rotation rate over geological time. Their work, much of it published in the 1960s and 1970s in the context of understanding ancient sea level changes, showed that the redistribution of the equatorial bulge is one of the slowest but most thorough rearrangements a planet can undergo. We are not talking about decades. We are talking about millions of years before the planet's shape would meaningfully approach a true sphere. But the process would have begun the moment rotation ceased, and it would never stop until it was complete. There is something profoundly humbling about this image. The continents themselves, the rocks beneath your feet, are not fixed. They are participants in the planet's spin. Stop the spin, and even granite begins eventually to flow. The mountains we know, the Andes, the Rockies, the Himalayas, were formed by tectonic processes that depend on the slow circulation of the mantle, and that circulation is itself subtly organized by rotation. We will return to this when we talk about the core, but for now, hold the image of a planet whose very shape is unmaking itself, slowly, quietly, beneath whatever new sky has formed above. We have descended now from the stratosphere to the seafloor and into the upper layers of the rock. The next layer is darker, hotter, and stranger than anything we have visited yet. It is the layer that produces the magnetic field. And what happens to the magnetic field on a non-rotating Earth is one of the most consequential and least appreciated parts of the entire thought experiment. Most people think of the Earth's magnetic field as a kind of decoration. It moves a compass needle. It produces auroras. It is invoked in vague terms when migratory birds are mentioned. But the magnetic field is one of the principal things keeping the surface of the planet habitable. It is a vast, invisible bubble surrounding the Earth, deflecting the solar wind, blocking the most energetic charged particles from the Sun and from interstellar space. Without it, the upper atmosphere would be stripped, slowly, by the relentless flow of particles from the Sun. Mars, which once had a stronger magnetic field and lost it billions of years ago, demonstrates the consequence. Its atmosphere is now less than 1% the density of Earth's, partly because the solar wind has been peeling it away ever since the Martian dynamo failed. The Earth's magnetic field is generated by the geodynamo, a process taking place in the outer core. The outer core is a layer of molten iron and nickel, about 2,200 kilometers thick, lying between the rocky mantle above and the solid iron inner core below. The fluid in the outer core is in motion. It rises and falls, driven partly by heat escaping from the inner core and partly by compositional differences as the inner core slowly grows by freezing the liquid above it. And, crucially, its motion is organized by the planet's rotation. The Coriolis effect operates inside the core just as it does in the atmosphere, only on a much grander scale. The convective rolls of liquid metal are stretched by rotation into long columnar structures aligned with the planet's axis. These columns of moving conductive fluid generate the magnetic field through electromagnetic induction. The full theoretical basis for this picture was assembled across decades, but two names stand out. Walter Elsasser, the German-American physicist working in the 1940s, was the first to argue rigorously that fluid motions in a conducting core could sustain a planetary magnetic field. Edward Bullard, the British geophysicist, refined and extended this model in the 1950s. By the late 20th century, The geodynamo theory was confirmed by laboratory experiments, computer simulations, and the discovery that other planets with liquid conducting cores, Mercury, Jupiter, Saturn, also have magnetic fields, while planets without such cores, like Mars and Venus today, do not. Now end the rotation. What happens to the dynamo? This is where the popular intuition runs aground. There is, in theory, a clear fix. Some sources will tell you that the dynamo simply switches off. The magnetic field collapses immediately. The planet is exposed to the solar wind. This sounds dramatic and is the easy answer, and it is what you find in many casual treatments of the question. Lean into it for a moment, because it sounds plausible. After all, if rotation is what organizes the convection, then no rotation should mean no organized convection, and no organized convection should mean no field. But here is what that solution doesn't account for. Convection in the outer core does not need rotation to exist. It only needs a temperature difference between the bottom and the top. As long as the inner core is hotter than the lower mantle, fluid in the outer core will continue to rise and fall, just as a pot of water on a stove will continue to convect, even if you do not stir it. Without rotation, the convection would no longer be organized into long axial columns. It would be more chaotic, more turbulent, less efficient at generating a coherent global magnetic field. But it would not necessarily stop entirely. What would happen more likely is that the magnetic field would weaken substantially and become disorganized. Instead of the orderly dipole field we have today, with a clear north and south magnetic pole roughly aligned with the geographic poles, the non-rotating Earth would have a weaker, more chaotic field, perhaps with multiple poles wandering across the surface, or with no coherent global pattern at all. Computer simulations of dynamos in the absence of rotation, performed by groups including Gary Glatzmeyer, first at Los Alamos in the mid-1990s and later at the University of California, Santa Cruz, together with Paul Roberts at UCLA, have shown that such non-rotating dynamos can sustain weak, irregular magnetic fields, but they cannot reproduce the strong, dipole-dominated field of rotating planets. Some researchers think the field would persist at perhaps 10 to 20% of its current strength in a chaotic configuration. Others think it would collapse over thousands of years to functional invisibility. The truth is, we do not know with certainty. What we do know is that the protective bubble around the Earth would shrink dramatically. The solar wind, which today is held off at a distance of about 10 Earth radii on the day side, would press in much closer. Solar storms would penetrate the upper atmosphere with a violence we never see today. The planet would begin, in slow geological terms, to leak, to lose its lighter atmospheric gases to space, just as Mars did before us. This is the quiet third catastrophe of the non-rotating Earth. The wind has died, the oceans have moved, and now the sky itself begins, very slowly, to thin. There are no flames, no shock waves, no thunderclaps. There is only an invisible erosion taking place at the very top of the atmosphere, where the solar wind nibbles steadily at the upper layers and carries them away into space. Over hundreds of millions of years, the atmosphere becomes thinner. The sky, on the day side, fades from blue towards something paler, then thinner still. Eventually, on geological timescales, the planet begins to look more like Mars and less like the Earth we know. Pause here, because this is the moment when the thought experiment shifts from being about disaster to being about loss. The wind kills, but the wind ends. The ocean moves, but the ocean settles. The magnetic field, however, simply fades. And with it fades the protection that has allowed complex life to exist on the surface for hundreds of millions of years. There is no single catastrophic moment for the magnetosphere. There is only a long, gentle erosion, a slow undressing of the planet. And that, somehow, is more haunting than any of the violences we have visited so far. We have walked now through 3 layers of consequence: the atmosphere, the hydrosphere, and the magnetosphere. Each has shown us something the simple version of this question does not contain. The wind that is not really wind. The ocean that becomes 2 oceans, separated by an unbroken belt of exposed seafloor. The magnetic field that does not vanish but degrades, leaking the planet's air into the dark. And we have not yet visited the strangest layer of all. We have not yet spoken about light, about the day that does not end, about what happens biologically and ecologically when a planet's most fundamental rhythm, the alternation of light and shadow, ceases to exist. That is the next descent. And it is, in many ways, the heart of the story. Because the planet is not just a physical object. It is a host of life. And life, in every form we know, has been shaped second by second by the rising and setting of the sun. Stop the spin, and the rhythm stops with it. What grows in its absence is something the biosphere has never had to face before. Picture yourself standing on the surface of the non-rotating Earth, somewhere on the day side, in the long calm after the wind has died and the dust has settled. The sun is fixed in the sky. It does not move. It does not rise. It does not set. It simply hangs in a single position at whatever angle your latitude affords. If you happen to be standing exactly at the sub-solar point, the place directly beneath the sun, it is at its zenith, blazing down from straight overhead. Step 1,000 kilometers to one side, and it sits a little lower. Step further, and it descends toward the horizon. Walk far enough to the terminator, the boundary between the lit and unlit hemispheres, and it touches the horizon and stays there in eternal sunset for as long as you remain in that place. Try for a moment to feel what this means in the body rather than the mind. There is no morning. There is no evening. There is no afternoon shadow lengthening across a wall. There is no anticipation of sunset, no relief of dawn. The angle of the light is fixed. The temperature, modulated only by the great convection wheel of the atmosphere, is steady in a way no temperature on Earth has ever been steady. The shadow of a tree, if any tree could grow there, falls in the same direction at the same length every hour of every year. Time, in the way you have always experienced it, has been amputated. This is the most fundamental thing the rotation gave us. Not just heat, not just weather, but rhythm. The slow tide of light and shadow that we call a day is the smallest unit of biological time on this planet. Every organism, from the cyanobacteria in the surface waters to the redwoods of the Pacific coast, to the human beings who watch this video, carries within it a circadian clock, a chemical oscillator that, with extraordinary precision, anticipates the next sunrise and the next sunset. The first researchers to identify the molecular basis of this clock were the geneticists Jeffrey Hall, Michael Rosbash, and Michael Young, whose work on the period gene in fruit flies, conducted across the 1980s and 1990s, eventually earned them the Nobel Prize in Physiology or Medicine in 2017. What they revealed was that the rotation of the Earth is not just a feature of the environment. It is written into the DNA of nearly every living thing. End the rotation, and the clock ceases to mean anything. The cells of plants still produce, on a roughly 24-hour cycle, the proteins that signal them to open their stomata, to flower, to begin photosynthesis. But the environmental cue these cycles were tuned to, the alternation of light and shadow, is gone. The clock continues to tick in isolation against a background that no longer changes. Over generations, in any organism that survives, natural selection would slowly erode these circadian rhythms. They would become vestigial, like the small bones of a whale's hind legs, evidence of an ancestral environment that no longer exists. The genetic record of the spinning Earth would, in time, be quietly written over. A future ecologist on the non-rotating planet, assuming any could exist, would find, embedded in the genomes of the organisms there, the ghost of a rhythm that had not been functional for 10 or 20 million years. This is one of the truly haunting consequences of stopping the spin. Because the loss is not visible. There is no body, no graveyard. The clocks simply stop being useful. And the long evolutionary history that produced them is reduced in the scale of geological time to a kind of fossilized expectation, embedded in molecules that no longer have anything to anticipate. The biosphere, of course, would not vanish. Life on this planet has proven extraordinarily resilient. There is life in the boiling water of hydrothermal vents, in the sub-zero dryness of Antarctic dry valleys, in rock kilometers underground, in the brine of evaporated lakes. If any of the catastrophes of the stop did not directly kill an ecosystem, that ecosystem would continue in some form into the New World. And the New World would, over millions of years, develop new ecosystems suited to the new conditions. The ecosystems would form bands. On the day side, near the sub-solar point, the heat would be intense. Whether this region would be habitable depends on details: atmospheric circulation, cloud cover, ocean proximity, that are not perfectly predictable. In some climate models, the subsolar region becomes a planetary desert, hot enough that liquid water cannot persist on the surface. In others, the rising air at the subsolar point produces persistent cloud cover, and the cloud cover shades the surface, keeping it relatively cool. The cloud-covered version is the more interesting scenario because it suggests that even the hottest part of the day side could host some kind of life. Move outward from the subsolar point. The sun sinks lower in the sky. Temperatures drop. Eventually, you reach a band, a kind of latitude in this new geometry, but defined by angular distance from the subsolar point rather than from the equator, where conditions are temperate. Here, in this ring of subsolar twilight, plants could grow, if any plants survive to evolve into this niche. The light would be perpetual, but slanted, like an eternal autumn afternoon. The temperature would be moderate. The wind, organized by the planetary convection wheel, would blow steadily in from the night side and out toward the day side, in great inflowing rivers of cold air rising and warming as they approached the heat at the center. Continue outward. Cross the terminator. You are now in eternal twilight, then eternal night. The sky is dark, but full of stars that do not move. Temperatures plummet. On the deepest night side, where no sunlight has fallen for an indefinite time, the surface freezes. Ice forms. If the atmosphere is thin enough or cold enough, even carbon dioxide and other gases begin to condense onto the surface, forming a kind of dry gas frost on the rocks. This is not science fiction. It is what happens on the night side of every planet without an atmosphere thick enough to redistribute heat. The non-rotating Earth, depending on the strength of its atmospheric circulation, could see something similar in its deepest, oldest night. Within these bands, life would adapt. Some organisms would specialize in the perpetual sunlight near the subsolar point. Others would thrive in the eternal twilight ring. Still others, perhaps the descendants of today's deep-sea microbes and chemosynthetic bacteria, would persist in the dark, frozen night side, using chemical rather than solar energy to fuel their metabolism. planet would not be lifeless, but it would be utterly, unrecognizably different. There would be no migrating birds, because the cues that drive migration, day length, seasonal temperature change, would not exist. There would be no dawn chorus, because there would be no dawn. There would be no winter, no spring, no summer, no autumn in the local sense. Only the slow annual circuit of the sub-solar point as the planet orbited the sun, dragging its day and night belts across the geography. Now zoom out, step back from the surface. Picture the whole planet from a vantage point in space. You can see the day side, fixed beneath the sun. You can see the great convection cloud at the sub-solar point, rising into the upper atmosphere like a permanent storm. You can see the polar oceans, two great blue caps, glistening at the top and bottom of the world. You can see the equatorial supercontinent, a long brown belt circling the planet from east to west. You can see the terminator, a ring of perpetual dawn and dusk, where the cloud structures stretch in great spiral arms outward from the sub-solar point. You cannot see the magnetic field, but you can see, faintly, the auroras dancing in the upper atmosphere of the night side, fed by the unimpeded solar wind that now reaches deeper into the magnetosphere than any aurora on the modern Earth. It is a beautiful planet in its alien way. Not the planet we know, but a planet, functional, coherent, with its own logic, with its own life, dressed in patterns that the spinning Earth never wore. We have walked now through the principal layers of consequence: atmosphere, hydrosphere, lithosphere, magnetosphere, biosphere. There is one more layer to visit before we begin the climb back up. It is the most distant of all, in a sense, even though it is the layer we look at every night. It is the sky, not the air, the sky, the dome of stars and planets and moonlight. Because the sky, we see, is not just a passive backdrop. It is, in profound ways, a product of the Earth's rotation, and what happens to it when the spin ends is one of the most beautiful and least obvious changes of all. Stand on a hilltop in the dark, on the modern Earth. Look up. The stars wheel. They do not appear to move quickly, but they do move. Over the course of an hour, you can see Orion shift, the Big Dipper rotate around Polaris, and the Milky Way drift slowly across the sky. This wheeling is not the stars moving. It is the Earth turning beneath them. The stars are, on the timescales of human life, fixed. The motion you see is your own motion. The night sky is a planetarium projected by the Earth's rotation. End the rotation. The stars stop wheeling. They do not move at all over the course of any human scale period. From any given point on the night side of the non-rotating Earth, the same stars are visible, in the same positions, indefinitely. The constellations that happen to be overhead at the moment of the stop become permanent residents. The stars not visible from your location become permanently invisible. There is no longer a night sky in the modern sense, a single celestial canopy slowly unrolling overhead. There are local skies, fixed forever to local geography. Or rather, and this is where the subtlety enters, almost fixed forever, because the Earth is still orbiting the Sun. Over the course of 1 year, as the planet completes its orbit, the half of the sky that is on the night side at one point in the orbit becomes the half on the day side 6 months later. So the stars do shift. They shift on an annual timescale rather than a daily one. From any given location, the visible stars at night change slowly across the year, sweeping through the constellations in a way that, on the rotating Earth, is masked by the daily wheeling. On the non-rotating Earth, this annual sky tour is the only motion the stars make. A given star rises, very slowly over the course of a few weeks. It dominates the sky for a few months. Then it sets, just as slowly, and disappears for half a year before returning. What this means for any culture or civilization that might exist on the non-rotating Earth is that the calendar would be the most important measurement of time, and there would be no day to subdivide it. Time would be measured in years, in months, in the slow drift of celestial bodies across the unchanging sky. Astronomy would be transformed, perhaps simplified. The same stars, in the same places, for as long as you cared to observe them. And perhaps deepened, because the parallax effects of the Earth's annual orbit would become the only baseline against which stellar distances could be measured directly from the surface. The Moon, too, would behave differently. On the modern Earth, the Moon rises and sets each day because the Earth rotates beneath it. On the non-rotating Earth, the Moon's apparent motion would be governed only by its own orbit around our planet. It would still complete that orbit in roughly 27 days, but it would do so against a background of fixed stars and a fixed sun. From any given location, the Moon would rise and set roughly once per orbital period, once every 27 days, give or take, rather than every 24 hours. A lunar day on the non-rotating Earth would be nearly a month long. The phases of the Moon, which on the modern Earth shift gradually each night against the changing daily sky, would unfold instead against an almost stationary heaven, the sun and stars holding still while the Moon slipped through them in its slow ellipse. Stay with this image for a moment, because there is something about it that is, in its own way, more profoundly different than any of the catastrophes we have visited so far. The wind kills suddenly. The ocean rearranges in a year. The magnetic field weakens over millennia. But the sky changes shape almost the instant rotation ends, and it never goes back. The constellations that have wheeled over every human eye since before the species existed simply stop wheeling. The familiar dance of the heavens, which every culture in human history has built into its myths and its calendars and its rituals, becomes a single still photograph, slowly redrafted only by the planet's annual march around the sun. There is something else worth saying before we leave the layer of light and rejoin the layer of consequence. We assumed, in framing this thought experiment, that the Earth simply stops rotating on its axis while continuing to orbit the sun. That is one possible version. But there is another version, and it has a different feeling entirely. If the first scenario is an ending, this one is a long afternoon. A planet still alive, but only on one side. The Earth becomes tidally locked to the sun. One face turned forever toward the star, the other turned forever towards stars that never set. This is what happens to many planets in close orbits around their stars, and it is the most likely fate of any planet whose rotation has been brought to rest by tidal forces alone. In the tidally locked version, the day side is permanent. The night side is permanent. The annual drift of the subsolar point does not occur. The geography of light and shadow becomes fixed for as long as the planet exists. Some climate scientists, including modelers studying potentially habitable exoplanets around red dwarf stars, have devoted significant effort to understanding what such worlds would look like. Researchers like Manoj Joshi at the University of East Anglia have explored in papers across the 2000s and 2010s the possibility that even tidally locked planets could support liquid water, particularly along their terminator zones, where the eternal twilight produces moderate, life-friendly temperatures. This research, originally aimed at understanding alien worlds, gives us our best window into what a non-rotating, sun-facing Earth would actually look like. The terminator zone, the narrow ring of perpetual sunset between day and night, emerges from these models as the most habitable place on such a planet. The day side is too hot, the night side too cold, but the terminator is just right. If life persisted on the non-rotating Earth, the great cities and forests and ecosystems of any future biosphere might well concentrate along this twilight ring, in a band running pole to pole, dividing the world. Imagine that. A continuous band of life, circling the planet from north to south, sitting in the eternal blush of a sunset that never deepens. To the east, the burning day. To the west, the frozen night. And in between, this thin strip of livable temperatures, livable light, livable air. On the modern Earth, life is spread across the surface in great, continuous swaths. On the non-rotating Earth, in the tidally locked version, life would be a narrow ribbon, a coast of light around a planet of extremes. We have, by now, descended through every major layer of consequence, and we have begun to glimpse the alien architecture of a non-rotating Earth. The wind, the ocean, the rock, the magnetic field, the biosphere, the sky, each has been transformed in ways that are stranger and more profound than the simple cinematic disaster the question seems, at first, to invite. But there is a question that has been hovering over all of this, a question we have so far been able to keep at the edges of our attention. It is the deepest question this thought experiment can ask, and the time has come to confront it directly. What does it actually mean for a planet to stop spinning? Not in the mechanical sense, not in the sense of which fluids slosh and which rocks shift and which atmospheres thin, but in a deeper sense. What is rotation really? Why does it matter that this particular ball of stone and metal and water happens to be turning on its axis at this particular speed? Could it have been otherwise from the beginning? Could there have been an Earth that never spun? Could there be one again, somewhere else in the galaxy, where a planet of our size, with our distance from a similar star, simply does not turn? And what would such a world tell us about ourselves, about the precariousness of the conditions that produced us, about the role of accident in the long story of a biosphere? These are not questions that have clean answers. Some of them have no answers at all. They press against the edge of what science can currently say. But they are the questions this thought experiment was always pointing toward, and we owe it to the question to ask them properly, even knowing we cannot fully answer them. Why does the Earth spin in the first place? What gave it the angular momentum it now carries? The standard answer is that the spin was inherited from the rotating disk of gas and dust that formed the solar system about 4.5 billion years ago. As that disk collapsed inward to form the sun and the planets, conservation of angular momentum required that the resulting bodies retain some of the original rotational motion. The Earth's spin is, in this sense, a fossil of the solar nebula, a relic of the slow, cold cloud of interstellar matter from which our entire planetary system condensed. But this answer raises another question. Could the disk have rotated more slowly or differently? Could the Earth have ended up with a slower initial rotation or a faster one? The answer, in modern planetary science, is yes. The rotation rates of planets are surprisingly variable. Mercury rotates extraordinarily slowly, completing one rotation every 59 Earth days. Venus rotates even more slowly, and in the opposite direction from its orbit, completing one rotation every 243 Earth days. As early as 1968, the planetary scientist Thomas McCord proposed that Venus's strange rotation might be the result of a giant impact early in the planet's history, an impact that nearly stopped its spin and even reversed it. The idea was formalized decades later by Alex Alimi and David Stevenson at Caltech in 2006. If such an impact had been slightly different, Venus might rotate forward, like Earth, or it might rotate not at all. So the rotation of any given planet is the result of a long contingent history. Initial conditions in the protoplanetary disk, early collisions, tidal interactions with moons and the central star. The Earth's particular rotation rate, fast enough to produce a strong magnetic field, slow enough to allow stable surface temperatures, oriented in such a way as to give us seasons through axial tilt, is not necessary. It is a particular outcome among many possible outcomes. There are surely planets in our galaxy and beyond that look very much like the Earth in size and composition and distance from their stars, but which spin much faster, much slower, or hardly at all. Some of those planets, perhaps, host life. Most do not. We do not know how the spin rate distribution shapes the probability of life, because we have so far only one detailed example of a life-bearing planet to study. Now stay with this for a moment. What we are really asking, when we ask what would happen if the Earth stopped spinning, is something larger than the question pretends to be. We are asking what role the rotation has played in the entire architecture of habitability. We are asking whether the planet beneath us, the one we have always assumed was a stable, given thing, was in fact only one possibility among many. We are asking whether the air we breathe, the rain that falls, the auroras at the poles, the seasons of our childhoods, are all consequences of a single contingent fact, that this particular ball of rock, 4.5 billion years ago, happened to start turning at this particular rate, and has continued turning with only the slightest deceleration ever since. How much of you is the spin? How much of the planet you call home, the planet you take for granted, would survive its own stillness? If the rotation had been only a little different from the start, would the magnetic field have been weaker, the atmosphere thinner, the climate more extreme, the conditions for life narrower? Could there be Earths in other star systems where the difference between life and lifelessness is not a question of water or chemistry or distance from a star, but a question of how fast the planet turns? Would we recognize a sister Earth sitting in the right orbit around a sun-like star with all the right ingredients, but rotating once every 50 days as a place that could have produced us? Or would we look at it from a great distance and see only an alien world? And here is the deepest version of the question. Here is the place where the thought experiment opens onto something larger than itself. Could the Earth have produced us at all if it had ever, even briefly, ever stopped? Could complex life have emerged on a planet that did not have day and night? Could there have been minds of any kind in a world without the small daily rhythms that organize sleep and waking, attention and rest, observation and dream? Are minds themselves a product of rotation? Is consciousness, the kind of consciousness that builds clocks and writes physics papers and asks questions like this one, a feature of a particular kind of spinning world? We do not know. We cannot know. The only example of complex consciousness in the universe that we have direct access to is our own, and it arose on a planet with a 24-hour day, on a body whose every cellular cycle is calibrated to that day. We cannot run the experiment again with a different parameter. We cannot stop the spin and see what kind of mind, if any, eventually emerges. The non-rotating Earth, if it ever existed, would have to evolve its own forms of life, its own forms of awareness, its own answers to the question of what it means to live in a place where time does not pulse. And it occurs to you, slowly, in the way these things sometimes do, that the question we have been exploring is not really a question about a planet. It is a question about ourselves, about the substrate of every thought we have ever had, about the fact that the rhythm of the Earth's rotation has been beating beneath every human heartbeat since the first one, and that we have never noticed, and that we cannot quite imagine what we would be without it. Could you sleep in a place where night did not come? Could you wake in a place where dawn was not a promise? Could you love someone for a long time without the small ritual of saying goodbye in the evening and finding them again in the morning? Could you remember your own childhood in a place where the seasons did not turn? Could you mourn in a place where every year was the same length of light and shadow, the same temperature, the same color in the sky? What does it mean to be human on a planet that is not turning? And is there even an answer, or is the question itself a kind of category error, a mistake in grammar, a sentence that points to nothing because the conditions for its meaning have been quietly subtracted? Some of these questions are not answerable in any direct way. They press up against the edge of what we can currently say with science. They are the kind of questions that mark, in a quiet way, the end of certainty and the beginning of wonder. We can describe with some confidence what would happen to the wind, to the oceans, to the bedrock, to the magnetic field, to the sky. We can describe with somewhat less confidence what would happen to ecosystems and biology. But what would happen to mind, to memory, to meaning? These we cannot describe at all. The non-rotating Earth, in this sense, is not a thought experiment about geophysics. It is a thought experiment about what makes us us. And the answer is hidden somewhere in the slow, invisible pulse of a rotation we have never felt. There is one more piece of this question that deserves to be stated clearly, even if it is uncomfortable. The Earth, eventually, will stop. Not soon. Not in any time frame that human civilization, or even the human species, is likely to witness. But the slow tidal interaction with the moon, which has been gradually lengthening our day for billions of years, will continue. If the Earth and the moon survived long enough, which they will not, because the sun will swallow them both first. The Earth's rotation would eventually slow until our planet became tidally locked to the moon, just as the moon is already tidally locked to us. One face of the Earth would always face the moon. The other would always face away. A day on the Earth would last as long as the orbital period that emerged at the end of this slow drift, perhaps 47 of our current days. The full process would take roughly 50 billion years, long after the sun has already swelled into a red giant. The sun will die long before then, in about 5 billion years. The Earth will likely be vaporized or stripped of its atmosphere or pulled into the swelling red giant. The end point will not be reached, but the direction is real. Our planet is, in a quiet, almost imperceptible way, slowing down. Each century, a tiny amount. Each year, a fraction of a millisecond. The day you were born was very slightly shorter than the day on which you are listening to this. By the time you finish watching this video, the Earth's day will be longer than it was when you started, by an amount too small to measure in any practical sense, but real and real in the same direction as the thought experiment we have been exploring. We are, all of us, riding a planet that is gradually approaching, by infinitesimal increments, the very condition we have been imagining together. And there is no danger in this. There is only a kind of slow grandeur. The Earth is not, as some headlines occasionally suggest, in any imminent risk of stopping. The sun will die first. The moon will drift away first. The species will, almost certainly, vanish or transform first. The actual stop, if it ever happens, belongs to a future so distant that no projection of our civilization or our biology can meaningfully reach it. What this thought experiment lets us do, in the meantime, is glimpse the shape of a world that we ride toward only in the slowest imaginable sense. And through that glimpse, see ourselves and our home more clearly than we usually allow ourselves to. Stay in this strange place for a moment longer, because we do not get to come back here often. We do not, in everyday life, get to ask what the planet is, what we are, how much of one is the other. The thought experiment of the non-rotating Earth is a permission to hold those questions up to the light. And what the light shows us is not a monster, not a catastrophe, not a disaster movie. It shows us, instead, the architecture of a quiet bargain between rock and air, gravity and motion, light and shadow, time and life, that has held mostly for 4.5 billion years, and that has produced, against all the odds of the contingent universe, this moment in which a body listening to a voice can wonder about the world it lives in. Now we cool down. We have climbed to the top of the question and looked over its edge. We need to come back, slowly, to the surface of the actual Earth, the one that is still spinning, and to spend a little time among the things we know and love before we close. So step back in your imagination from the great cosmic frame and return to a small particular place. Stand on a hilltop in the early evening on the rotating Earth. The sun is low, the light is gold. A breeze is moving through the grass. You can hear very faintly the sound of a stream somewhere below you. Water sliding over stones it has not yet finished smoothing. The breeze is the planet turning. The light's slow descent toward the horizon is the planet turning. The gathering of shadows under the trees, the cooling of the air against your skin, the first stars beginning to appear. All of these are the planet turning. None of them are signals you would have on the world we have been imagining together. None of them would survive the stop. Hold the breeze. Hold the goldenness of the light. Hold the sound of the stream. These are not given. They are not necessary. They are the gifts of a particular planet with a particular spin, in a particular orbit around a particular star. They are the gifts of the bargain we described at the very beginning, the quiet exchange between atmosphere and ocean, crust and core, magnetism and light. The bargain is invisible, and it is also everywhere. It is in the fact that you can hear a sound at all. It is in the fact that the air carries that sound. It is in the fact that there is air. It is in the fact that the air is not, at this moment, a wall of 1,700 kilometers per hour pressing you into the ground. Walk along the hilltop. The grass is damp. The moisture is the dew. The dew is a product of overnight cooling, of the temperature dropping below the dew point, of moisture in the air condensing on cooler surfaces as the night deepens. This entire small, wet, glittering miracle requires that night exists. It requires that the surface, having spent the day absorbing heat from the sun, has now spent the night radiating that heat away into space, cooling enough for the moisture in the air to gather on the blades of grass. On the non-rotating Earth, no such daily cycle would exist. The grass, if there were grass, would not bear dew in the evening. There would be no evening. Listen again to the stream. Water is falling somewhere, finding its way down through bedrock to the sea. The stream is fed by springs, the springs by groundwater, the groundwater by rain, the rain by the great hydrological cycle of the modern Earth, evaporation from the oceans, transport by wind, condensation in clouds, precipitation over land. This whole cycle, this great quiet engine of life, is shaped by rotation. The trade winds that carry moisture across the tropics, the westerlies that bring rain to temperate latitudes, the seasonal monsoons that drench half the world, all of them are children of the Coriolis effect. Stop the spin, and the cycle does not vanish, but it becomes simpler, less productive, less varied. There would be rain in some places on the non-rotating Earth, but not the kind of rain that produces a small stream sliding over particular stones in a particular hilltop in particular evening light. Sit down for a moment. Feel the ground beneath you. The ground is cool, less cool than it will be in an hour, more cool than it was at noon. The temperature of the ground beneath you is a product of the day. The day itself is a product of the rotation. Every quality of the world you know, the temperature, the humidity, the angle of the light, the song of the birds, the time of evening, is held in place by the spin. You do not feel the spin, but you feel everything that the spin does. Look up. The first stars are beginning to appear. Venus, perhaps, near the horizon. The brightest stars of whatever constellation is rising. In an hour, the sky will be full of them, slowly wheeling overhead, the same wheel they have made for every human eye that has ever looked up. The wheel is the spin. The spin is the wheel. End the spin, and the stars stop wheeling. They become a single fixed photograph, and what was a slowly turning dome becomes a kind of cosmic hieroglyph frozen above the place you happen to be standing. There is a particular kind of beauty in the wheel. The fact that it is in motion is part of what makes it beautiful. We do not usually register the slow turning of the night sky as a thing of beauty in itself, because it is too slow to perceive in any single glance. But over the course of an hour, if you watch carefully, you can feel it. The Big Dipper rotating around Polaris, Orion climbing in the east, the Milky Way drifting overhead like a slow river of stars. This motion, almost too slow to see, is one of the most fundamental things about the place we live. And it is beautiful in part because it is a sign that we are turning, that the planet is alive in this small, gentle, mathematical way, that the bargain is being kept. Stay on this hilltop a little longer, because there is something here that the mind needs to settle on after the long descent we have made together. The thought experiment of the non-rotating Earth is, in the end, a celebration. It is a way of finding language for things we never thought we would have to talk about. The wind that carries the sound of a stream up a hillside. The dew that gathers on the grass in the evening. The slow wheeling of a constellation across the sky. The breath you just took, the next breath you will take, the breath after that. All of these are signals that the planet is doing what it has been doing for 4.5 billion years. The bargain is intact. The spin continues. The world goes on. The light has dimmed a little while you have been here. The first sounds of night have begun. A bat, perhaps, somewhere over the trees. A distant owl. The wind has shifted slightly as the day's heat releases from the ground and rises into the cooling sky. Each of these small phenomena is rooted in rotation. Each is a private, almost secret signal of the planet's aliveness. And each, on the world we have been imagining together, would be subtracted, leaving a different planet in its place. Not necessarily a worse one, not necessarily a dead one, but a different one, with different signals, different rhythms, different gifts. You will not need to remember everything we have walked through together. The wind speeds and the ocean redistributions and the geodynamo equations are details. They are scaffolding. What matters is the shape of the thing. What matters is the realization that the planet you live on is not a backdrop. It is an active participant in everything you experience. It is doing things all the time that hold the world in the configuration that produced you, and it has been doing them without rest since long before you were born, and it will continue doing them without notice for as long as you live. The least we can do, knowing this, is to notice, even if only for a moment, even if only on a hilltop in the gold of an evening that the planet, by its quiet turning, has prepared. Now we make our last ascent. Because there is, in any honest exploration of a question like this one, a moment when the thought experiment opens onto something even larger than itself, something that requires us to step back from the planet entirely and consider what this strange exercise in counterfactual physics has actually been about. We have spent these hours imagining a world, and the imagining has, in its quiet way, taught us something about our own. It is time to say what. Human civilizations across every era we have records of have built their entire understanding of time on the rotation of the Earth. The Egyptians divided the daylight into 12 parts and the night into 12 more, calibrated to the changing length of the day across the seasons. The Sumerians, in the 3rd millennium before the Common Era, developed the sexagesimal system that the Babylonians later inherited and refined, giving us 60 seconds in a minute and 60 minutes in an hour, all of it scaffolding for the measurement of a single rotation. The Mayan calendar, the Chinese calendar, the Hindu calendar, the Islamic calendar, all are, at their root, attempts to organize human life around the cycles produced by the spin and the orbit. Every clock on every wrist, every appointment in every diary, every harvest schedule, every ritual fast, every prayer time, is a downstream consequence of the fact that this ball of rock and water and metal happens to be turning. Consider for a moment the Antikythera mechanism, the bronze astronomical computer recovered from a Greek shipwreck off the island of Antikythera in 1901 and partially decoded across the 20th century by researchers including Derek de Solla Price, whose 1974 paper revealed its astonishing complexity. Built sometime around 100 BCE, the precise date still debated, but almost certainly within the late 2nd or early 1st century before the Common Era. The mechanism could predict the positions of the sun and the moon, calculate eclipses, and track the 4-year cycle of the ancient Olympic Games. It is, by any measure, one of the most extraordinary artifacts of the ancient world. And every gear in it, every meshing tooth, every hand-cut bronze pointer was designed around the rotation of the Earth and the orbits of the bodies visible from its surface. Take the rotation away, and the mechanism is meaningless. The orbits remain, but the daily cycles vanish, and most of what the device was designed to predict no longer exists. This is true, in a softer way, of every human cultural achievement that organizes itself around days. The 7-day week, traceable in some form back to Mesopotamia and made familiar through the Babylonian, Hebrew, and later Greco-Roman traditions, is a unit of time only because there are days to count. The hours of monastic prayer in medieval Europe, matins, lauds, prime, terce, sext, none, vespers, compline, are tied to the slow march of light across the cloister wall. The 5 daily prayers of Islam, the morning and evening services of Judaism, the dawn rituals of Hinduism, the evening vespers of the Eastern Christian churches, all of them are calibrated to a rotation that no one praying ever sees, but that everyone praying depends on. Take the rotation away, and the entire architecture of human time begins to crumble. Not because the prayers cease to be meaningful, or because the calendars cease to function, but because the substrate on which they were built has been removed. A non-rotating Earth could still keep time. It could still measure years by counting orbits around the sun. It could still divide those years into shorter periods by some agreed-upon convention. But the divisions would no longer be tied to anything the body could feel. Time, on a non-rotating Earth, would become a purely intellectual measurement, divorced from the rhythms of waking and sleeping, of light and shadow, of work and rest. It would be, for the first time in human history, abstract. There is a parallel here, perhaps, to what has already begun to happen in modern industrial civilizations. The advent of artificial light, of round-the-clock labor, of global trade across time zones has, in subtle ways, already begun to detach human time from the natural rhythms of the spinning Earth. The factory worker on a graveyard shift, the long-haul pilot crossing time zones, the trader watching markets in 3 different cities, the patient in a hospital intensive care unit lit 24 hours a day. All of these, in their small ways, are inhabiting a kind of time that the non-rotating Earth would universalize. The chronobiologists who study these patterns, researchers like Till Roenneberg in Munich, whose work on what he termed social jet lag was published across the 2000s and 2010s, have shown that disrupting the body's circadian rhythms has measurable effects on metabolism, mood, immune function, and life expectancy. We are, even now, in some quiet way, beginning to live as if the planet were not turning. And the cost of that, biologically, is real. So the thought experiment of the non-rotating Earth is, in a strange way, a mirror held up to choices we are already making. We are not, of course, going to stop the planet's spin, but we are slowly, almost without noticing, becoming a species that no longer organizes its days around the planet's day. The dimension of the question becomes ethical, almost. What do we lose when we forget that the spin is what we are made of? What kind of creature do we become when our schedules and our screens and our flights and our cities mute the rhythm that wrote our DNA? There is one more historical parallel worth offering before we close. In 1929, the Soviet Union, in an attempt to industrialize as rapidly as possible, briefly abolished the 7-day week and replaced it with a 5-day week called the Nepririvka, the continuous work week. Each worker was assigned one of 5 colors, and each color had its rest day on a different day of the cycle. The result was that families could not rest together. Friends could not gather on the same day. The collective rhythm of the country, which had been built up over centuries, was shattered in the name of efficiency. The experiment was deeply unpopular, was modified into a 6-day week in 1931, and was finally abandoned in 1940 with a return to the 7-day cycle. It is one of the few times in modern history when a state has tried to reorganize the basic unit of human time. And it failed decisively because the rhythm it was disrupting had been written too deep into the species to be replaced by decree. The non-rotating Earth would be the same experiment, run not at the scale of a calendar, but at the scale of biology itself. It would not be a state attempting to redefine the week. It would be a planet attempting to redefine the day. And the result would not be, in any straightforward sense, the death of life. Life is too resilient for that. The result would be the slow rewriting of every rhythm, every cycle, every clock, until eventually, after enough generations, the species that had once lived on a spinning planet had been replaced by descendants who had never known one. Those descendants, looking back at us, might have difficulty understanding what we mean when we use the word day. They would have inherited in their genes the fading echoes of our circadian clocks, but they would not feel them. The way we, looking back at the early Earth, can describe the 400-day year of the Devonian period, but cannot really feel what it would have been like to live in that compressed, hurried world. This is what the thought experiment in the end is offering us. Not a vision of catastrophe, not a warning, but a perspective. The chance to step outside our own time, our own rhythm, our own world for the length of a long script, and to look back at ourselves with a little more care than we usually allow. The earth is spinning. You are spinning with it. The air around you is spinning. The water in your body is spinning. The bones of your skull, the cells of your retina, the molecules of your blood, all of them are participating in a slow, vast, invisible rotation that has been going on since before the first single-celled organism on this planet ever divided. And it has shaped you. Every part of you. From the chemistry of your sleep, to the cadence of your hunger, to the patterns of your memory. You are not separate from the spin. You are an expression of it. And the question of what would happen if the Earth stopped spinning is, in the deepest sense, the question of what would happen if you were no longer the kind of creature you are. Now, slowly, we close. The story of the non-rotating Earth is one we have walked through carefully, layer by layer, from the wind above your roof to the iron at the planet's center to the constellations in the sky. We have seen the gale that is not a gale, but a wall of moving air. We have seen the oceans drain from the equator and gather in two great basins at the poles, leaving behind a continuous belt of land that stretches all the way around the world. We have seen the slow flow of solid rock as the equatorial bulge begins to relax. We have seen the magnetic field weaken into incoherence, the protective bubble around the planet shrinking, the upper atmosphere quietly leaking into space across millions of years. We have seen the long, strange aftermath in which the sun no longer rises, the stars no longer wheel, and life, what is left of it, gathers in narrow bands along the terminator, in the eternal blush of a sunset that does not deepen. And we have seen, beneath all of this, the question the thought experiment was always asking. What is the spin? Why does it matter? What did it give us? And what would we be without it? We have answered some of these questions with the language of physics and biology and geology. We have left others open because they cannot be closed by any current science. The question of what becomes of mind, of meaning, of memory on a planet that does not turn. These we have looked at and acknowledged and let stand in their open, beautiful uncertainty. The thought experiment ends here, but the planet does not. Right now, while you have been listening, the Earth has continued its slow, quiet rotation, never breaking rhythm, never asking permission. The breath you took at the beginning of this script was a slightly different breath from the one you are taking now, because the air has moved, and you have moved, and the planet has moved, all of you together in the great coordinated motion that we have spent these hours imagining the absence of. You did not feel the motion then. You do not feel it now. But it is there, beneath every other thing. Take that breath in. Let it out, slowly. Somewhere above you, the air is racing eastward at the speed of a passenger jet, dragged by a rotation so steady, so ancient, that your body mistakes it for stillness. The bargain is intact. The atmosphere is still bound to the surface. The oceans are still in their basins. The magnetic field is still bright around the planet, deflecting the solar wind. The sun is still rising and setting somewhere in the world on schedule. The stars, tonight, will wheel as they have always wheeled, slowly, almost imperceptibly, across whatever sky is over your head. The dew in the morning will gather on the grass, because there will be a morning. The bargain holds. We have, in this long descent and ascent, walked through a counterfactual world and returned. The earth that has waited for us all this time is the one we know. The one with the wind that carries the sound of streams. The one with the dew on the grass in the evening. The one with the slow turning of the night sky, drifting overhead in a great soft wheel that has wheeled for every human eye that has ever looked up. We never had to leave. We just looked for a little while at what would be subtracted if the planet were ever to grow still. And the look was a kind of thanksgiving. There is no danger in this thought experiment. The Earth is not, in any near future sense, going to stop. The slowing of our planet's rotation, driven by the gentle gravitational handshake with the Moon, will take hundreds of billions of years to reach anything like a tidal lock, and the Sun will swell and die long before then. The spin we live on is, for any timescale that means anything to us, eternal. What this thought experiment offered us was not a warning. It was an invitation. An invitation to feel for a little while the architecture of the world that produced us, by imagining what would happen if it were quietly removed. And what we found in the imagination is that the Earth's rotation is not a feature of the world. It is the architecture holding the world together. It is the bargain we named at the very beginning, between atmosphere and ocean, crust and core, magnetism and light. Every layer we visited turned out to be, in some essential way, a child of the spin. The wind, the rain, the rivers, the rock, the magnetic field, the day, the night, the stars in motion, the rhythm of the body, the structure of consciousness. All of these are gifts of a particular planet turning at a particular rate, in a particular orbit, around a particular star. You were never separate from any of it. You are not standing on the planet. You are part of the planet. The same matter that is in your bones is in the bedrock beneath you, and the same motion that carries the bedrock around the axis carries you with it. The spin is not happening outside you. The spin is happening inside you, in the slow molecular oscillations of your circadian clock, in the cyclical rhythms of your hunger and your sleep, in the way your eyes adjust to the lengthening shadows of an evening you have lived through 10,000 times. You are the spin. The spin is you. There is no place where one ends and the other begins. This is the quiet truth at the heart of the question. And it is the reason, in the end, that the thought experiment is not frightening. We have looked into the absence of the spin, and we have found, on the other side of the absence, ourselves. We have found that the wind that would arrive, if the planet stopped, is the very same wind that, today, lifts a kite in a park and carries the smell of coming rain across a field. We have found that the oceans that would drain to the poles are the very same oceans that today lap at the harbor walls and carry the salt of every summer afternoon. We have found that the magnetic field that would slowly fade is the very same field that, today, is dancing as auroras over Tromsø and Yellowknife and the southern coasts of Tasmania, in colors most of the human species will never see in person, but will know about, because they happen, because the field is alive, because the spin is alive. If this changed how you think about the air above your head, or the water in your glass, or the slow turning of the stars at night, then the time was well spent. If you find yourself tomorrow morning registering the dawn just a little differently, as something the planet has prepared for you by turning all night while you slept, then the time was very well spent indeed. The spin will not stop. The bargain will hold. The dew will be on the grass. The streams will carry the sound of running water up the hills. The stars will wheel slowly, almost imperceptibly across whatever sky is over your bed. Take a slow breath. The air is not still. It is moving with you, with the planet, in the great coordinated motion that has carried every breath ever taken on this world. You can feel it now, perhaps, in a way you could not feel it before. Not as wind, but as participation. The bargain between atmosphere and ocean, crust and core, magnetism and light, is being kept in this exact moment on your behalf by a planet that has been keeping it for 4.5 billion years and will keep it for billions more. There is nothing you have to do. The spin is not asking anything of you. It is only continuing, quietly, steadily, as it always has. Thank you for staying with me through all of this. Thank you for following the thought experiment all the way down, through the air and the water and the rock and the iron core, and back up to the surface, to the hilltop, to the slow gold of an evening light that the planet, by its quiet turning, has prepared. Thank you for letting the question take its time. Thank you for being here, in this body, on this world, with this voice, in this moment, on a planet that has not stopped, will not stop, and is even now while you breathe, carrying you and all of us gently eastward into the next quiet rotation of a world that has never, for an instant, asked to be noticed, and yet has earned, perhaps, just this once, our small and quiet attention. Sleep well. The earth is turning. The air is moving. The bargain holds.